Hello, I would like to provide a demonstration for NC programming in Cimatron version 14. What we have is an aerospace type part with lots of 2D machining of pockets on different levels, and I'm going to show how Cimatron's automation can quickly automate 2D type programming. Let's begin by changing some colors. So I'm going to make the part green, and I'm going to put some patches over some of these holes real quick. Cimatron has excellent modeling tools inside the NC solution. So we're going to do the islands, keep original, and take the inside. And wherever my mouse is on the computer screen, I can hit apply, stay in the function, and keep on repeating the steps. And then when I'm done, I hit the big check mark, and it takes me out of that feature. Next, I'm going to color that face cyan, and I'm going to set a color mask so that it only picks the selected color. And just like that, we're able to get all of those colored as well. And now let's go look at the sets. So Cimatron is pretty unique in how it handles sets or levels. Everything that I colored green automatically falls onto the set called part, and everything that I color cyan automatically falls onto the set called patches. And I've taken the time to just organize a couple more sets. I've got the part faces from side 1, and check faces from side 1, and then part faces from side 2, and check faces from side 2. So just that little bit of organization is going to drive all of our templates here in a minute. I also have a set called NC, which is the whole part. Actually, I think I want to include those patches in that, so I'm going to choose Edit and include those patches. And so all the templates are going to reference these sets for the geometry that's being picked. So we'll switch over to the cam side, and before we apply the template, I'm going to show something else that's new in version 14, and it's called the Pocket Manager. So I go into the Pocket Manager, and actually I'm going to do this after I apply the template, because right now I've got a coordinate system from the top side, but I don't have a coordinate system from the bottom side. And one of the benefits of applying the templates is that it's going to automatically create the coordinate systems from different sides. So I go to Template, Apply Template, and take this multiple toolpath template and apply it. Okay, and you can see that these coordinate systems were created from the template. So the template is made to machine from the top side and the bottom side. It could also be all 4 sides, or whatever you want. And each toolpath folder represents machining to within, say, 5 or 10 thousandths on the top side, and then 5 or 10 thousandths on side 2, and then going back and machining side 1 to 0 and machining side 2 to 0. Before we calculate these, I now want to go ahead and show the pocket manager. Alright, and so now when I pick on the UCS 12, that's the top side UCS, and I'm going to say select all displayed surfaces, and it goes in and tries to figure out basically what would be a 2D contour. Now it can recognize open contours, so like this one could be a valid contour, but I don't want that one, so I'm going to delete it. And then over here we've got a couple that I don't want, so we'll delete those. Alright, and then everything else here are valid pockets, and you can kind of see what it's doing. It's representing the high point and low point of each pocket. So wait a second. Yeah, so now we're going to go back to the templates, and okay, here's the 2-axis pocket. So this one is the closed contour pockets, and this one is open contour pockets. So let's start with the closed contour. And what we say is select them by the NC pockets. It brings up that list that we just created, and I can just box pick all these guys and say OK. Alright, and then we're going to do the next one, which is the open contours by NC pockets, and pick these ones. Alright, and then we got one more from the other side. So I think we need to go back to the pocket manager really quick, and we're going to change the UCS to be the bottom UCS. Select all displayed surfaces. Okay, and here's the pockets from the bottom side. And actually these pockets on the bottom side have 1 degree of taper on the walls, and I did that on purpose in order to make sure that this could handle that type of condition. Alright, now we go here and we select the contours by the NC pockets, and just box pick all these guys. And save and close. And now, if you'll notice, there's a little C next to all of these procedures, and that means criteria. So it's looking for the set NC plus the Z stop, or open contour. Basically, they're all going to be driven by sets. Yeah, in fact, I want to show one more thing before we calculate here. So on the CAD side, one thing that I did is I untrimmed this bottom, not the islands, but the boundaries. We're going to keep original, and we're going to do trim. And then we're going to do an offset. And let's see, keep original. We'll go 1/8 of an inch. Whoops, that's not what I wanted to do. That's alright, we'll delete this one. Alright, so this is going to be our Z stop face. And I have a set here called Z stop. So we're going to add this one to that one. Alright, and oh yeah, one last thing to define. We're going to use the automated drilling. So before we calculate, we want to set up the automated drilling. Alright, so here we go into automated drilling, and the part surfaces are already picked. We're going to go to the group manager and just pick all this stuff. So here's all the holes that are going to be machined. Yeah, that's actually right. Okay, so it puts over here all the different groups of the holes, and if we wanted to manually apply sequences, we could say define sequence, and it will bring this up and show us what the hole looks like. And you program one hole and it takes care of all the Z values all over the job. But we're not going to have to do that. We're just going to go to the auto fit sequence. Hold on, one here. Okay, so we're going to auto fit for all unassigned groups. And so it's going to go through my library and look for previously saved sequences, and it will attach them according to a geometric range. And this works really good with imported data. It doesn't matter if the part was drawn in SolidWorks or CATIA or whatever. It's very flexible on how we set up the geometric range so that it works whether you have chamfers on the holes or thread attributes. Okay, and then we're going to say save and calculate. Alright, and so the drilling is done just like that. I told it that it had 5-axis capability to rotate 90 degrees, so it did all of the holes in one shot. Alright, so now we're ready to go ahead and calculate all this stuff. So I'm going to minimize these 4 toolpath folders and hit execute. And we'll take a look at the result here when it's done. I will mention that this is background calculation, so while it's calculating we can actually keep working. We could keep running other programs. We don't have to wait for the calculation to take place in order to keep working.